You know what the biggest problem is with studying objects from other star systems? We almost never get to see them. In the entire history of modern astronomy, we've only confirmed 3 interstellar objects passing through our solar system. So when 3I Atlas showed up on July 1st, 2025, scientists knew they had a limited window to gather data before it disappeared forever. They pointed the Hubble Space Telescope and the James Webb Space Telescope at it, and what they discovered was shocking.
The Hubble Space Telescope report includes a successful detection of the nucleus of 3I Atlas based on post-perihelion data.
This thing has a nucleus 1.6 miles across. That's 40 times more massive than the last interstellar comet and 20,000 times heavier than Oumuamua. But here's the real problem. Webb detected methane gas coming off this comet, but only after it got close to the sun. That's completely backwards. Methane is hypervolatile. It should have evaporated first, not last. It's like finding ice cubes that only melt after you take them out of the oven. Scientists think they've figured out what's going on, and the solution reveals something incredible about this object's billions of years wandering through interstellar space. The outer layers got stripped away by cosmic rays and radiation, depleting all the surface methane. What we're seeing now is pristine, unprocessed methane from deep inside, like opening an ancient time capsule.
Detection of the nucleus of 3I Atlas through the subtraction of the best fit coma model from the observed Hubble images for each observational visit.
I'm going to show you exactly what the latest Hubble and Webb data revealed, and why this changes everything we thought we knew about interstellar visitors. Subscribe to Space Aquarius and let's begin. On October 29th, 2025, 3I Atlas made its closest approach to the Sun at a distance of about 130 million miles. That's roughly the same distance as Earth's orbit. Then, on December 19th, it passed within 167 million miles of Earth. Now, that might sound far away, but in cosmic terms, that's practically a close encounter. And during this whole time, both Hubble and Webb were watching it like hawks, gathering data that's now causing quite a stir in the scientific community. Here's what makes this so fascinating. When the Hubble Space Telescope finally managed to detect the actual nucleus of 3I Atlas between December 2025 and January 2026, they measured it at about 1.6 miles in diameter. That's assuming it has a typical comet surface that reflects about 4% of the light that hits it. To give you a sense of scale, that's roughly the size of a small mountain, but size isn't what's got scientists puzzled. It's what this thing is made of and how it's behaving. The James Webb Space Telescope, using its incredibly sensitive infrared instruments, detected water vapor, carbon dioxide, carbon monoxide, and methane in the comet's atmosphere. Now, water and carbon dioxide? That's normal for comets. But the methane detection is where things get really interesting, and frankly, really weird. See, methane ice is hypervolatile. That means it evaporates at extremely low temperatures, much lower than water ice or even carbon dioxide ice. Think of it like this. If you had a block of dry ice and a block of regular ice sitting next to each other, the dry ice would disappear first because it turns to gas at a much lower temperature. Methane is even more volatile than dry ice. So when 3I Atlas was still far from the Sun back in August 2025, when it was about 3.3 astronomical units away, that's about 307 million miles, scientists expected to see methane evaporating first. But they didn't see any methane at all, zero. Instead, what they saw was carbon dioxide and carbon monoxide pouring off this thing. The carbon dioxide production was absolutely massive, accounting for about 87% of the total gas being released. Water made up only about 4%, and carbon monoxide was around 9%. This is completely backwards from what we see in comets from our own solar system, where water is usually the dominant gas. But then, as 3I Atlas got closer to the Sun and warmed up, something changed. By December 2025, when it was at about 2.2 astronomical units from the Sun, roughly 204 million miles, the Webb telescope finally detected methane. And not just a little bit. The methane production was running at about 14% to 27% of the water production rate, depending on when they measured it. That's actually quite a lot. So what's going on here? Why would the most volatile substance be the last thing to show up? Scientists have a theory, and it's pretty wild. They think that the outer layers of 3I Atlas got stripped away or processed somehow during its billions of years wandering through interstellar space. Maybe it got hit by cosmic rays, or maybe it passed through clouds of interstellar gas that eroded its surface. Whatever happened, it seems like all the methane ice that was originally on the surface got depleted long ago. But here's the kicker. There's still methane deeper inside. When the sun's heat finally penetrated deep enough into the comet's interior, it started releasing this pristine, unprocessed methane that had been locked away for billions of years. It's like peeling back the layers of an ancient time capsule. Now, there's another mystery that's got scientists talking. The carbon monoxide showed up early, even though it's also more volatile than carbon dioxide. How does that make sense? Well, researchers think that the carbon monoxide might not be original to the comet. Instead, it could be a byproduct of radiation hitting the carbon dioxide and methanol ice over billions of years. Laboratory experiments have shown that when you bombard carbon dioxide ice with radiation, it can create carbon monoxide. So the carbon monoxide we're seeing might actually be evidence of the comet's long journey through space, a chemical signature of its age. The Hubble observations revealed something else that's pretty remarkable. When 3I Atlas was at its closest point to Earth on January 22, 2026, something called an opposition surge occurred. This is when the Sun, Earth, and the comet all line up, and suddenly the comet appears about 20% brighter than you'd expect. This happens because of the way light scatters off the dust particles in the comet's tail. It's like when you're driving at night and your headlights hit a road sign, it suddenly lights up much brighter than the surrounding area. Scientists measured this opposition surge very precisely, and it tells them a lot about the size and properties of the dust grains surrounding the comet. Speaking of dust, there's something really interesting about how 3I Atlas is losing material. The comet isn't just releasing gas, it's also throwing off icy grains that continue to sublimate as they float away from the nucleus. Hubble's observations showed that water production extends far beyond the nucleus itself, creating what scientists call a distributed source. These icy grains can travel thousands of miles from the nucleus before they completely evaporate, creating an extended cloud of water vapor around the comet. But here's something that really caught scientists off guard. 3I Atlas is fading much faster on its way out of the solar system than it brightened on its way in. Most comets show some asymmetry between their approach and departure, but this one is extreme. The activity index, which measures how quickly a comet's brightness changes with distance from the sun, was measured at 4.5 on the outbound leg. That's significantly higher than the 3.8 measured on the way in. What this tells us is that the comet's surface changed dramatically during its close encounter with the sun. Maybe fresh ice got exposed and then quickly sealed over with dust, or maybe the heat caused structural changes in the nucleus itself. There's also the question of what this tells us about the planetary system where 3I Atlas came from. The fact that it's so rich in carbon dioxide suggests it formed in a very cold environment, probably in the outer reaches of another star system. The enriched methane levels, once we account for the surface depletion, also point to formation in an extremely cold region. This comet might have formed in conditions similar to the outer edges of our own Kuiper belt, or maybe even farther out in what would be another star's Oort cloud. One of the most intriguing aspects of this whole discovery is what it means for the population of interstellar objects out there. Based on the detection of 3I Atlas and statistical modeling, scientists estimate that at any given moment, there's at least one object of this size within about 420 million miles of the Sun. But here's the thing, we probably missed a bunch of them. The researchers who analyzed the Hubble data concluded that several similar objects likely passed through our inner solar system between the mid-1990s when automated sky surveys started and 2017 when we discovered Oumuamua. We just weren't looking carefully enough, or they passed through when we weren't watching the right part of the sky. This raises a pretty profound question. How many of these ancient wanderers are out there? If we're seeing roughly one every few years now that we're paying attention, and we probably missed several before that, the galaxy might be absolutely teeming with these interstellar nomads. Each one is a messenger from another star system, carrying information about how planets and comets form in different environments across the galaxy. The Webb telescope also detected something unexpected: atomic nickel in the comet's atmosphere. This was seen as a forbidden transition at a wavelength of 7.507 micrometers. Now, nickel doesn't just float around in space by itself. Scientists think it's being released from organometallic compounds, basically organic molecules with metal atoms attached to them. When sunlight breaks apart these molecules, it releases the nickel atoms. This is fascinating because it suggests that 3I Atlas contains complex organic chemistry the kind of stuff that could potentially be related to the building blocks of life. What's really remarkable is how much we've learned from just a few weeks of observations. The combination of Hubble's sharp visible light imaging and Webb's sensitive infrared spectroscopy gave us an unprecedented look at an object from another star system. We measured its size, its composition, its rotation, how its activity changes with distance from the Sun, and even the properties of its dust grains. Each piece of data is like a clue in a cosmic detective story, helping us understand not just this one object, but the nature of planetary systems throughout the galaxy. As 3I Atlas continues its journey back into interstellar space, traveling at over 36 miles per second, it's heading toward a future we can barely imagine. In a few thousand years, it'll be light years away, perhaps eventually encountering another star system. And maybe billions of years from now, astronomers around another star will spot it passing through their neighborhood and wonder where it came from. The discovery and study of 3I Atlas represents a new era in astronomy. We're no longer just studying our own solar system. We're getting direct samples of material from other star systems, delivered right to our doorstep. Each interstellar visitor teaches us something new and challenges our assumptions. And if the pattern holds, we won't have to wait too long for the next one. Somewhere out there, right now, another ancient traveler is making its way toward our sun, carrying secrets from a distant corner of the galaxy. The question is, will we be ready to catch it? If you found this discovery as fascinating as I did, make sure to hit that subscribe button so you don't miss our next deep dive into the mysteries of space. Drop a comment below and let me know what you think about 3I Atlas. Do you believe we've missed other interstellar visitors in the past? And if you know someone who'd be blown away by this story, share this video with them. The more people who understand what's happening in our cosmic neighborhood, the better.